Dear students, in this video series, I am going to discuss on computer graphics and multimedia. For convenience in understanding, I have prepared a presentation, and with the help of presentation, I am moving ahead. So, let us start with definition. Computer graphics is branch of computer science that deals with generating images with the aid of computers. Graphics are composed of pixels and vector graphics are composed of paths. So, these graphics, to execute these graphics or to prepare the graphics, we do image processing and picture analysis. Computer graphics concerns the pictorial synthesis of real or imaginary objects from their computer based models, whereas the related field of image processing or picture processing treats the converse processes. The analysis of scenes or the reconstruction of models of two-dimensional or three-dimensional objects from their pictures. So, picture analysis is important in many arenas like aerial surveillance photographs, slow scan television images from planets, television imaging taken from industrial robots, chromosome scans, X-ray imaging, computerized axial tomography popularly known as CAT scans, and fingerprint analysis. So, these are important for computer graphics. Though image processing or picture analysis have some sub areas as image enhancement, which deals with improving image quality by eliminating noises. Noises, I mean extraneous or missing pixel data, or by enhancing contrast. The another sub area, that is pattern detection and recognition, which is used to detect and clarify standard patterns and finding deviations from these patterns. A particularly important example in optical character recognition, popularly known as OCR technology, which allows for the economical bulk input of pages of typecast or typewritten or even handwritten characters. The next sub area, that is scene analysis and computer vision, which allows scientists to recognize and reconstruct a three-dimensional model of scene from several two-dimensional images. We have seen in industries that robot senses the relative sizes, shapes, positions and colors of parts of conveyor belt. Although both computer graphics and image processing deals with computer processing of pictures, they have until recently been quite separate disciplines, but now both use raster displays. However, the overlap between these two is growing, as a particularly evident in two areas. The first is interactive image processing. Human inputs instructions via menus and other graphical interaction techniques, which helps to control various subprocessors while transformation of continuous tone images which are shown on the screen in real time. For example, we may take a scanned in photographs are electronically touched up, cropped and combined with others, even with synthetically generated images before publications. And the next one, that is simple image processing operations, which are often used in computer graphics to help synthesize the image of model. Certain ways of transforming and combining synthesis images depend largely on image processing operations. So, we have some primitives as a basic non-divisible graphical element for input or output within a computer constitutes graphics systems and also known as primitives. Some primitives are known as input primitives, whereas some are known as output primitives. Output primitives have attributes such as line style and patterns associated with them, whereas input primitives are locator choice and valuators. Input primitives often have a style of echoing associated with them. So, with these primitives, with the use of these primitives, we use the graphics analysis, but during the analysis we faces some terminologies, some difficulties like aliasing, jaggis, etc. So, aliasing in computer graphics, the process by which smooth curves and other lines become jagged because the resolution of graphics device or file is not high enough to represent a smooth curve is called aliasing. Smoothing, which is a technique used by some pointers to make curves look smoother. Jag is stair like lines that appear where there should be smooth straight lines or curves. So, to overcome these we use anti-aliasing, which is a software technique for diminishing jaggis, and we all knows that pixels are the core upon which all this depends. So, let us look at on pixels, that pixels which are teeny dots and looks different on different devices. We may say that a pixel is a sample which has no dimension, which does not occupies any area, and even it cannot be seen, but it has coordinate with a value. We may say that pixel is neither a box nor a disk or teeny little light rays. So, these are the characteristics by which we know that what a pixel stands. Now, we extract samples from signals. So, taking samples from signals is very important part in computer graphics, I mean picture analysis or synthesis. Signals is a function that conveys information. We refer to signals in the spatial domain rather than in the temporal domain. A spatial domain, I mean as a function of space coordinates, whereas the temporal domain is termed as function of time. Although images are two-dimensional functions of two independent spatial variables x and y. Signals can be classified by values at all points in the spatial domain. a continuous signal is defined at a continuum of positions in space. A discrete signal is defined at a set of discrete points in space. So, we may define sample and sampling as the process of selecting a finite set of values from a signal is known as sampling, and the values which are identified or selected are called samples. Sampling is a technique used to digitize analog information. Once these samples are selected, then these are displayed using a process known as reconstruction that attempts to recreate the original continuous signal from the samples. The array of pixels in the frame buffer is reconstructed by the graphic system's display hardware, which converts these discrete intensity values to continuous analogous voltage that is applied to the cathode ray tube electron guns. The methods we used are identified in two ways. One is point sampling and another is area sampling. The most straightforward way to select each pixel's value is known as point sampling, whereas the objects fallen between samples are being missed suggests another approach integrating the signal over a square centered about each grid point, dividing by the square's area and using this average intensity as that of pixels, termed as area sampling. So, these are the two ways by which we take samples. We use some theory, so those are termed as sampling theory. Sampling theory provides an elegant mathematical framework to describe the relationship between continuous signal and its sample. In the spatial domain, signals are represented as a plot of amplitude against spatial portions. Signal may also be considered in the frequency domain, that is, these may be represented as a sum of sine waves, possibly offset from each other. The offset is called phase shift and having different frequencies and amplitudes. In this theory, we have a term that is known as Nyquist rate. The minimum rate at which a signal can be sampled without introducing errors, which is generally the twice the highest frequency present in the signal, and this is termed as Nyquist rate. So, thus we do sampling of signals, and after getting the samples we do a scan conversion, that is the initial of reconstruction the signal. So, in next session we will start the scan conversion for that. Okay, thank you.